In this lecture, I will be discussing how to read raw data into Python IDE. In previous lectures, we learned how to open raw data in LTspice and plot the waveform manually. Also, we can export the data as text file. However, it becomes more challenging if we have more raw data files. What if we have hundreds or thousands of raw data files? It would be tedious and time-consuming to repeat the same process just by hand. The good news is Python can do this for you, so that you can spend your valuable time in other important things, or just take a break. More importantly, Python opened the door for you to a new world of data science. From my own experience, learning Python is an eye-opening experience and really broadened my horizons. I hope Python works for you as well. In this section, the objective is to read raw data into Python IDE. For example, we are using Spyder here. The best solution I have ever found is LTspice3.py. This is an open source code developed by Professor Torsten Lehmann from the University of New South Wales in Australia. So this is the download link for the source code, and this link is his website. I really appreciate his efforts in developing this code. It's a very simple to use, user-friendly code and free to use. There are a few key points that will be covered in this section. LTspice3.py, I call it LTspice3, is an open source Python module, so you can import it into Python and use it immediately. It is recommended to read through LTspice3 code and see how it works. But as an end user, you don't have to understand every single line in LTspice3. It is simple to use, even if you are new to Python. In this section, I will give you a quick demo to how to read raw data into Python IDE, and I will show you how to use LTspice3 module. I will teach you about each data format in LTspice raw data. As you may know, the data format is encoded in the raw data. It's like a secret because there's no official supporting document talking about the data format. I reverse engineered a few existing solutions and summarized the solution for you here. Most of commonly used simulations will be discussed. I will demonstrate how to read different raw data from various simulations, such as transient simulation, AC analysis, DC operating point, DC transfer function, and FFT. Now let's get started. In this quick demo, I will show you how to read raw data of transient simulation results into Python. Now let's go to the folder for this lecture. You can see that LTspice3.py is given here. And we have another code just to show you how to read raw data into Python. In addition, raw data is given called train_lpf. This is the transient simulation results of a low-pass filter. Now let's go to Spyder. To import the raw data, we can use the code shown here. First, we import the Python module LTspice3. We use LTspice3.simData to create a Python object called SD for simData. The input is a string. The name is just the raw data's name. By implementing that, all the raw data will be processed and saved as SD. SD.variables gives you the name of all the variables, and SD.no variables give you the number of variables. So SD.values give you all the data, including time and traces from the raw data. The first element in the SD.values is time. The rest will be the voltage or current you measured. For example, here we have two voltages, input voltage and output voltage. We can just hit run or shortcut key F5 to implement the code. So now you can see everything is implemented. Let's go to Variable Explorer. Let's first check the name variable, which is a list of 3 strings. Double click, you can see the three names variables are here: time, vin, and vout. Notice that the index starts from 0 to 2 for 3 elements. The number of variables is an integer, is simply 3. This is the time in a NumPy array. The data type is float 64, also known as time step, starting from index 0 at 0 second all the way down to index 1041 at 5 milliseconds. The total size is 1042. This is the whole data and voltage, time, Vin, and Vout. If we check Vin, this is input voltage over time at each time step. It's a list of 3 NumPy arrays. Last one is the voltage of Vin and Vout. Double click that, it is Vout. It's a list of 2 NumPy arrays. That's all for this demo. Now let me give you an overview of LTspice 3 module. Let's go to Python Spyder. We open the LTspice3.py. Once you open it, you can see all the source code for this module. In the beginning, there are quite a few important things about license, also some information about data format from binary files. In the beginning, there are a few modules imported to support the code, such as NumPy, sys, os.path. Starting from here, you can see a class keyword is used to create a template for Python object. The input is called a file name. So this is the comments here shown in green. The file name is the raw data. Sim data is the class to create an object called dat or data. Important notes are given in the comments about output data structure. If you scroll down, you can see there are quite a few functions defined. The first one is to underline init, 2 underlines. So this is the way to initialize attributes of a class. If you could scroll down, you can see the title, date, plot name, number of variables. You can see all the data and the attributes are starting from here. So they are coming from the header file of the raw data, which gives important messages, and they are imported as different attributes in the Python object. If you go down further, the raw data will be imported according to the type of simulation, because different types of simulation may generate different types of raw data format. So it's better to understand them. The specific data structure will be covered in the following lectures. If you go down further, there are a few supporting methods defined in the end of the code. This is the reference I used for this lecture. It is recommended to take a look at it. As an electrical engineer, I didn't have a chance to learn Python at school. I learned it all by myself. I started with this course called Python for Everybody. It is available in Coursera, and I bought the textbook for $10 from Amazon. This is a very good starting point if you are a beginner. Also, I found WC School's Python tutorial pretty straightforward and simple to use. Thank you very much. See you next time.